Hello everyone. Today I will try to uh, show you how to make mechanism analysis in SolidWorks, and it will be a basic analysis which consists of only the lines without using any link or 3D part. So it will be easier to make it compared to the 3D models. I will try to model slider crank mechanism as shown here. So it is a actually 4-bar mechanism. So we need to start with the assembly file. We we will not use the part. So first open an assembly file in SolidWorks. Then here we will use create layout. This allows us to make layouts in 2D. So when we see this screen, so layout is active here. I will draw links. So we have 3 links. One is this one. The other link is connected to this one, and there is a another link which is modeled as rectangular. So it is another link. You can give dimensions. So let's say this is 100 millimeters. Sorry. Let's say this is 150. The dimensions of this one is not important. Let's give something. So they are links we will use. We need to make blocks from these links. So first select the first link and click make block. So it is chosen. Okay. And select the other link, make block. Okay. And this is another link. So we need to choose all of the lines, make block. Okay. So we can delete this length. Now the dimensions cannot change. This is link 1, 2, and 3. And there is a fixed link also. And there is a relation here. We can see it. However, the relation is not defined here. So we need to select this point with control and the other point and select coincident. So now we can rotate this link around this point. So this is the fixed link actually because it is origin. And this point should be on this point also. So select these 2 points and make coincident. And let's say it is moving on this line. So this point also should be on this line. Let's make coincident also. Okay. So now we have the mechanism, the slider crank mechanism. Yes. Actually, I forgot. This should be also block. Otherwise, the motion study give error and it doesn't put a motor to this point. So we need to put a motor this point. We need to make this block also. Okay. All the elements are blocked now. So we can exit now from the layout. And we can go to the motion study. So we will select motion analysis and select the motor and put it to here, so it will rotate like this. 100 RPM. We can give anything from to here. We can give distance. It means 90-degree rotate in 5 seconds. We can give oscillation with frequency and degree. So for now, I will give RPM. Okay. And it is a 5-second analysis. We can make it longer, like 10 seconds. And if you click the calculate, it will calculate the motion. Oh, sorry. Sorry, there is a... Okay, I didn't give relation to this one. After making it block. And it should be horizontal also. Okay, go to motion study again. Calculate. So it will move like this. Now, we can take the results from here. If you click this one, it asks for the result. Which result you want? Displacement, velocity, acceleration. We cannot take forces for now. Let's say this one. You can take trace path, for example. Let's say for this point. Okay. So it gives the path of the motion. Okay. Also, you can get linear velocity, the magnitude, let's say, of this point. Okay. So this is the velocity of this point according to time. Or you can take the angular velocity, let's say, of this point, the magnitude again. Uh, Angular velocity will be between two lines. Okay. So the angular velocity is constant. It is 600 degree per second. If you convert RPM to degree per second, it will equal to this one. Also, you can draw linear velocity of this point with respect to time frame or with respect to anything else, like new result with respect to linear velocity of this point. Okay, this is the translational velocity of this point, and this is the linear velocity of uh, this point, the y-axis and the x-axis. Okay, that's all. If you have any question, you can ask, and we can make new videos.